Hello, I am Alisha and this is my presentation for Applied Machine Learning assignment. My project focuses on classifying bird species using deep learning. First, I built a model using CNN from scratch and later used transfer learning with ResNet 50 for more improved accuracy and generalization. The goal of this project was to classify 200 bird species from the Caltech UCSD birds dataset. I started by developing a CNN model to understand the basic learning process and later moved to transfer learning using ResNet 50. And at the end, the best model amongst the both was deployed on Hugging Face for live prediction. So the dataset that was used contained around approximate 4,000 training images and around 1,000 testing images across 200 bird species. Each image was resized to 224 by 224 pixels to match the ResNet input requirements. To improve generalization, I applied augmentation such as rotation, zoom, brightness change, and horizontal flipping. The dataset was also organized using annotation files, which were already given. Uh, so, so the CNN network that I built had three convolutional blocks with 64, 128, and 256 filters, each followed by batch normalization, max pooling, and dropout for regulation. After that, I added two dense layers, one with 512 neurons using ReLU activation, and the final output layer with 200 neurons for classification. However, the model shows severe underfitting with less than 1% accuracy and loss around 5.29 even after 30 epochs. I could not really figure out what the exact problem was. However, in my personal approach, after digging a little bit in, I think that it was due to the model being small, since we have 200 classes, which means per class there are approximately 20, around 20 to 30 bird images, or maybe even less. So this could be the possible issue. However, to overcome the limitations of CNN, I implemented transfer learning using ResNet 50, which is a pre-trained model on ImageNet. I removed the top layers and added my own, a global average pooling layer, a dense layer with 512 neurons, and a dropout with a final softmax output, which had around 200 classes. So at first, I froze all the base layers to retain the pre-trained weights, um, and then trained it for a few epochs, like approximate 3 epochs, and then gradually I unfroze the deep layers, which started from block 1, and a smaller learning rate of 3E5 was used for fine-tuning to ensure stable adaptation. Callbacks and early stoppings were also implemented to prevent overfitting and optimize learning. So as a result, it's evident that the top one accuracy increased to uh, here. The top one accuracy increased to 68.11%, and the average accuracy per class was 67.54%. Uh, so clearly, ResNet 50 was a way better model than CNN. And however, at the end, we finally deployed and trained the ResNet 50 model on Hugging Face using radio. And this app will allow users to upload any bird images and instantly get predicted species name. And this makes the model easily accessible and demonstrate how deep learning models effectively work. We can now move on to the demonstration part. So here, this is my Hugging Face app. Here, and we submit the image, and this is the live prediction. And apart from this, this is my IPYNB notebook. We can scroll down to the results page here. As you can see, ResNet 50, when we plot the graph, curve graph of ResNet 50 with fine tuning, we can clearly see how the learning rate has increased, how the training rate and the validation score has increased from here. Thank you.